In medieval towns, built almost entirely from wood, fire was the constant unspoken threat. A single overturned lamp, a stray spark from a hearth, or an enemy torch could erase an entire street in minutes. Yet records and surviving structures show that many timber homes resisted flame long enough to be saved, even in densely packed cities. This was not chance. Medieval builders used a deliberate fire-resistant coating applied directly to timber, a fire coat that slowed ignition, reduced flame spread, and bought critical time. It did not make wood fireproof, but it changed how fire behaved, and that difference preserved homes, workshops, and lives. Why medieval builders treated timber as a system rather than a weakness. Medieval people understood fire intimately. They cooked with it, worked metal with it, and heated homes with it daily. They also saw entire neighborhoods burn. Over time, builders learned that raw timber was not the problem. Untreated timber was. Wood could be conditioned to resist flame, just as it could be hardened against rot or insects. The fire coat emerged from this practical understanding. It was not a single recipe, but a class of mineral-based coatings that shared one goal: prevent wood from flashing into open flame. How the fire coat was made from common materials? The most widespread medieval fire coat was lime-based. Quicklime was slaked with water to produce lime wash, then thickened with clay, ash or fine sand. In many regions, builders added animal milk, casein or tallow to improve adhesion. The result was a mineral slurry brushed or rubbed directly into the timber surface. Once cured, it formed a thin, alkaline crust that bonded with the wood fibres. This coating did not burn. When exposed to heat, it absorbed energy and released moisture, slowing ignition beneath it. Why lime and clay changed how fire behaved. Fire needs heat, oxygen, and fuel. The medieval fire coat attacked all three indirectly. Lime and clay increased the ignition temperature of the wood surface, forcing fire to work harder before flames could take hold. The coating also sealed surface pores, limiting oxygen access. Most importantly, bound moisture within the mineral layer absorbed heat as steam when exposed to flame. This delayed charring and prevented sudden flare-ups, the kind that make wooden buildings collapse rapidly. Now let's talk about how builders actually applied the fire coat correctly. You know, the way it was put on mattered just as much as the ingredients themselves. Timber was first smoothed, but not polished, leaving just enough texture for the coating to grip onto. The fire coat was brushed on in several thin layers, each allowed to dry before the next was added. Builders paid special attention to high-risk areas: roof beams near hearth smoke, interior walls behind ovens, attic timbers, and those exterior walls facing neighbouring buildings. In towns, municipal ordinances often required visible lime-coated facades, not only for fire resistance, but as proof of compliance, really. So, why did this coating work especially well in urban fires? Well, medieval city fires often spread by radiant heat long before any direct flame made contact. The fire coat reflected and absorbed this heat, stopping neighbouring buildings from igniting all at once. Structures treated this way tended to char slowly rather than erupt into flames. That delay, it gave bucket lines, fire hooks and demolition crews a fighting chance to intervene. Contemporary accounts even describe buildings that blackened but didn't collapse, standing amid burned ruins like islands of survival. Now, how did this method stack up against bare timber and tarred wood? Tarred wood, which was commonly used for waterproofing, burned fiercely once it caught fire. Bare timber, on the other hand, ignited quickly and unevenly. But fire-coated timber behaved quite differently. It smoked, it charred, and it actually resisted the spread of flame. Even when fire did manage to penetrate the coating, it did so gradually. Medieval builders, you see, learned to avoid organic fire treatments and instead relied on mineral chemistry. Centuries before modern fire retardants followed that very same logic. Now, the thing is, this fire coat was never meant to be used on its own. It actually fit into a broader medieval fire strategy, you see. Builders would combine it with other clever features, like using thick timbers that, well, would char slowly, stone hearth surrounds to contain the flames, raised floors, and carefully controlled chimney paths. All these elements worked together to keep fire risks in check. Fire safety was architectural, not decorative. The fire coat was one layer in a system designed to slow disaster rather than prevent it outright. That philosophy reflected medieval realism. Fires would happen, but total loss was not inevitable. Now, how this knowledge can be applied today? Well, the same principles apply in modern natural building and restoration. Lime wash thickened with clay can still be applied to exposed beams, sheds, cabins, and historic structures. It remains breathable, non-toxic, and repairable. For practical use, wood should be clean and dry, coatings applied in thin layers, and high heat zones prioritized. This method is especially valuable where modern chemical retardants are undesirable or unavailable. Why the medieval fire coat faded from common use? Industrial paints promised permanence and convenience. Building codes shifted toward chemical solutions and synthetic materials. The old fire coat required maintenance and understanding. Yet it never truly failed. Where it remains in place, medieval timber still resists flame better than untreated modern lumber. Its disappearance was cultural, not technical. Why does this technique deserve renewed respect? The medieval timber fire coat represents a disciplined response to real danger using simple materials and careful application. It did not rely on miracles or secrecy. It relied on chemistry, observation, and repetition. In an age that often mistakes novelty for progress, this method stands as proof that effective fire protection existed long before modern industry. If this deep examination of medieval building science added value to your understanding of historical survival and architecture, support in the beginning by subscribing, sharing this episode, and helping ensure that practical knowledge forged by necessity is not lost again.